In 1969, humanity achieved something that once seemed impossible. For the first time in history, humans walked on the moon. Apollo 11 wasn't just a giant leap for space exploration. It inspired generations of engineers, inventors, and makers to build, experiment, and imagine what could come next. To celebrate that same spirit of innovation, this Moon Day, we designed a laser-cut rocket lamp powered by WLED and programmable LED rings, built from either plywood or cast acrylic. This project combines laser cutting, soldering, and simple electronics into a fun weekend build. We'd love for you to join us in celebrating Moon Day by building your own rocket lamp. Follow along as we show you how to build your own rocket lamp, then share your finished project with the MakerStore community. We can't wait to see what you create. Let's get started. With the CAD files downloaded, it's time to move over to the laser cutter. For this project, we're using Lightburn, but the process is very similar in most laser cutting software. Start by importing the CAD file into your workspace. Once it's loaded, you can position the design wherever you'd like on the material. Just click and drag the parts into place. Rotate them if needed, and make the most of your sheet. When you're happy with the layout, place your sheet of 3mm plywood or cast acrylic into the laser cutter and make sure it's correctly focused. From there, click Laser, review your machine settings, and press Start to begin the job. Now it's just a matter of letting the laser do the work. We're cutting one complete rocket from plywood and another from clear acrylic using exactly the same CAD file. So later we'll be able to compare how each material changes the finished lamp. Before wiring everything together, let's prepare the controller. Take a look at the bill of materials on screen. Everything you need for this project is available from MakerStore. Connect the D1 Mini to your computer using a USB cable. We chose the D1 Mini for this project because of its compact form factor, ease of use, and ability to drive the LED rings directly. Then open the WLED web installer in your browser. Click Install, select the correct COM port, and the installer will automatically upload WLED to the board. Once the installation is complete, connect the controller to your Wi-Fi network. After it's connected, click Visit Device to open the WLED web interface. We'll come back to this later once the rocket is fully assembled. Before we start assembling the rocket, let's build the lighting module. If you're already comfortable with soldering, you can use this diagram to wire everything up and skip ahead to the assembly section. Now let's connect the two LED rings. Start by stripping a small section of insulation from the end of each wire. This exposes the metal conductor and prepares the wires for soldering. We'll begin with the smaller 7-pixel LED ring. Solder the black wire to ground. Next, solder the red wire to VCC. VCC is the positive power connection for the LED ring. Then solder the yellow wire to data out, labeled DO. This is where the control signal leaves the first LED ring and continues to the next one. Now move to the larger 12-pixel LED ring. Solder the yellow wire to data in, labeled DI. Next, solder the red wire to the 5-volt pad. Then solder the black wire to ground. Once both rings are connected, trim away any excess wire to keep the assembly clean and tidy. Try to leave a little extra wire between the rings. This acts as strain relief and gives you a bit more flexibility during assembly. Next, let's prepare the controller. Start by stripping the insulation from the 3-core cable. Insert the red wire into the 5-volt hole on the D1 Mini and solder it into place. Next, solder the green wire to ground. Then solder the blue wire to D4. D4 is the default data used by WLED. This pin sends the control signal from the controller to the LEDs, so there's no need to change any settings. Once the joints have cooled, trim off any excess wire protruding through the back of the board. With the controller prepared, it's time to connect it to the LED rings. Simply follow the wiring diagram on screen. Connect D4 to data in, 5 volts to VCC and ground to ground. With the wiring complete, it's time to assemble the lighting module. Start by mounting the large and small LED rings onto the laser-cut mounting plate using the M2 by 5mm bolts and nuts. Next, secure the 3D printed diffuser over the larger LED ring. This helps soften the light and creates a more even glow. Finally, place the controller inside the 3D printed enclosure to protect the electronics and keep everything neat. With that, the lighting module is complete and ready to be installed into the rocket. Now comes the fun part, building the rocket. The rocket is designed to slot together just like a model kit or a Lego build, with each piece locking neatly into place. Start by installing the lighting module into the base of the rocket. Then simply add each panel one at a time until the rocket is fully assembled. In just a few minutes, your rocket lamp is ready for its first test. Connect the D1 Mini to your computer using a USB cable and open the WLED interface in your browser. To control each LED ring independently, create 2 segments. Set the first segment to start 0 and stop 7 for the small LED ring. Then create a second segment with start 7 and stop 19 for the larger LED ring. For the small LED ring, we've selected the Fire 2012 effect to simulate a realistic rocket exhaust. For the larger LED ring, we've chosen the Solid effect, allowing you to set it to any color you like. Feel free to experiment with different effects and colors to create your own unique rocket lamp. The plywood version has a warm, natural feel, while the acrylic version really lets the lighting take center stage. If you'd like to build one yourself, you can download the free CAD files from our website using the link in the description. If you enjoyed this project, don't forget to like the video, subscribe to the channel, and let us know in the comments which version you prefer. Thanks for watching, and we'll see you in the next project.